Section 3.3 Quadratic Functions. Our objectives are to define the three forms of a quadratic function, to find the vertex and intercepts of a quadratic function and sketch its graph without using a graphing calculator, and to convert from one form to the other. The first thing we want to talk about is the quadratic function. Remember, a quadratic function is a polynomial of degree 2. Also, the shape that our quadratic function makes is a parabola shape, which is kind of looks like a U. Some specific things we need to know is that the parabola can open up or can open down. It always has a vertex, which either is a maximum or minimum, depending on how it's opening. It always will have exactly one y-intercept because at some point in time your graph will have to cross the y-axis. It can have either 0, 1, or 2 x-intercepts, which we'll talk about in just a second, and it's symmetric about a line through the vertex called the axis of symmetry. So to look at our graphs, if I have a graph that has a vertex that hits on the x-axis, I know that this is going to have exactly one solution. I also know that this vertex is going to be a minimum vertex because it is the absolute lowest point on our graph. If I have a graph instead that goes like this, maybe, this is just one example. This hits the graph x-axis in two places, so it has two solutions. And I know that my vertex is now going to be a maximum vertex because it is the absolute highest point of my graph. And then the last case scenario for our x-intercepts is when our graph is maybe going something like this, where it doesn't cross the x-axis at all. So this would be no solutions. And then you have two imaginary answers if you were to do the quadratic formula or something on your equation. So there are different types of forms that we want to talk about. So the first form that we're going to talk about is going to be transformation form. So for transformation form, which is this equation right here, you have y equals a times quantity x minus h squared plus k. Of course, since this is transformation form, it's the most useful for finding the vertex. So the vertex in this case is h comma k. And then to find the y-intercept, remember from algebra 2, how do you do that? You plug 0 into x and then solve for y. And how do you find then the x-intercept? You plug 0 into y and solve for x. So that would be how to find the y-intercept and the x-intercept. The next thing that we're going to do is we're going to graph this. So remember, when you're graphing these, don't use your graphing calculator. We want to be able to do this without it. So it says, given f of x equals -4 times the quantity x minus 2 squared plus 5, find the vertex and the x and y intercepts, and then sketch a graph. So since this is in transformation form, the easiest thing to find would be the vertex. So that's the first thing I would do. So the vertex in this case is going to be our h value, which is 2, and our k value, which is 5. So 2 comma 5 is the vertex, and that's what I'm going to plot in my graph first. So now that I have my vertex on my graph, now I always like to look at my a value. So my a value in this case is -4, and that tells me how my graph is going to be opening. So since my a value is negative, I know my graph is going to open down. And then the next thing I want to do is find my x and my y intercept. So let's go ahead and find the x-intercept first. So to find the x-intercept, you plug 0 in for y and then solve. So 0 is equal to -4 x minus 2 squared plus 5. So I'm going to subtract the 5 and then divide by negative 4. So that would give me 5 over 4 equals x minus 2 squared. And then I want to get rid of that squared by taking the square root of both sides. And I'm running out of room, so I'm going to do that over here. So I would get plus or minus the square root of 5 over 4 equals x minus 2. And then, of course, to solve for x, we would add the 2 to the other side. So x is equal to 2 plus or minus. And remember, we don't like to have fractions underneath radicals, so I would separate that so it's root 5 over root 4. So the square root of 5 doesn't reduce, but the square root of 4 does, which is 2. So these would be my x-intercepts, and of course if I want to graph them, the easiest thing to do would be to just use your calculator to figure out what the value is equal to. So if I do that, if I do 2 and then plus root 5 divided by 2, I get 3.1118, so 3.12. So 3.12 would be somewhere in there. And then if I do the 2 minus root 5 divided by 2, I end up with x equals 0.881. So I'm going to leave it at 0.88, which would be here. Then the last thing I want to do is find my y-intercept. So to find the y-intercept, remember, you plug 0 in for x and solve for y. So y is equal to negative 4 times 0 minus 2 squared plus 5. So for this, 0 minus 2 is just negative 2. Negative 2 squared is positive 4. 4 times negative 4 gives me negative 16 plus 5 is negative 11. So my y-intercept would be 0, negative 11, or you can just write y equals negative 11. So since my graph only goes to 10, it's actually going to be off my graph somewhere around here. And then the last part I need to do is just sketch my graph. So to sketch my graph, I know that it's going to go something like this. And notice that in this case, since my vertex is the highest point, I know this is a maximum vertex. And also note that your vertex is what we call the axis of symmetry. So for my vertex, I know that if I were to cut this graph in half this way, each side of my graph would match up with the other side because, again, your vertex is the place where your axis of symmetry hits. And so then we say the axis of symmetry would be x is equal to the x-coordinate of your vertex. So x would be equal to 2 for the line of symmetry. So that is our transformation form. The next thing I want to look at is polynomial form. So polynomial form, which is right here, which we also recognize as being standard form, ax squared plus bx plus c. So it's the most useful for finding the y-intercept. So again, how do you find the y-intercept? You plug 0 for x and solve. So if I did that here, I get y equals 0 squared times a, which is 0, plus b times 0, which is 0. So we get 0 comma c. The vertex, which you have to know how to find, the x-coordinate is negative b over 2a. And then, of course, if you know the x-coordinate, how do you find the y-coordinate? Plug that into x and solve for y. So f of negative b over 2a. And then the x-intercept, again, what you do to find this is you plug 0 into y and solve for x, and it's the same thing we did for the y-intercept. I plugged 0 in for x and solved for y. It's just that it's easy to see it's 0 comma c. So let's go ahead and practice graphing this then. So if I want to graph this function, we want to find the vertex and x and y intercepts and then sketch the graph. So for this, I know that the easiest thing to do would be to find the y-intercept first, so I'm going to write that down. So how do I find that? I plug 0 in for x and solve for y, so I would get 0 comma 3. So when I plug this on my graph, I have 0, 1, 2, 3, which would be right there. And then the next thing that I want to do is find my vertex, because that's always very useful. So the vertex in this case, to find the x-coordinate, you get negative b over 2 times a. So in this case, notice your a value is 1, your b value is 2, your c value is 3. So negative 2 over 2 times 1 would give me -1. So if I want to find the y-coordinate, I take that and I plug it into my equation. So y equals -1 squared plus 2 times -1 plus 3. And then when I solve, I end up with a y-coordinate equal to 2. So my vertex is -1, 2. And then I have to find my x-intercepts. But if I look at this graph, if I look at my a value, I notice that it's positive. So my graph is going to open up. If my vertex is right here, my graph opens up, then will it ever cross my x-axis? No. So I already know without even solving that I'm not going to have any x-intercepts. So remember, the vertex is your line in symmetry where it cuts your graph in half. So if I have the point 0, 3 in my graph, then I would also have to have the point -2, 3, which would be right here. And then I could also plug in other points if I wanted to plug in 1 to figure out the y-coordinate, or -3 and figure out the y-coordinate. I could to see how my graph is going, but it's just going to go something like this. And that would be the sketch of my graph. Now, if I were to solve using the quadratic formula for my x-intercepts, I would notice that I would get a negative number underneath the radical, which is why in this case, when I solve, I have no x-intercepts, because you would end up with x is equal to -2 plus or minus the square root of -8 over 2, and I guess right here that means that we have two imaginary solutions, which is why I don't have any x-intercepts. So you would have seen that if you had solved using the quadratic formula. So if we look at B, let's go ahead and do this graph. So for this one, it says for the function -2x squared minus x plus 7, find everything that we just did in the last one. So again, the easiest thing to find first would be the y-intercept. So the y-intercept, if I plug 0 in for x, I get 0, 7. So 0, 1, 2, 3, 4, 5, 6, 7 would be right around there. And then the next thing I want to do is find the vertex. So the vertex would be your x-coordinate is equal to -b over 2 times a. So a is -2, b is -1, c is 7. So in this case, I get -1 over 2 times -2, and that ends up giving me -1/4. How do you find the y-coordinate? Plug that in for x into your equation and then solve. And when I do that, I end up with 57 over 8. And so, of course, the next thing I want to do is go ahead and plot this. So I have the coordinate -1/4, so -0.25, and then 57 over 8 is 7.125. So somewhere about right around in there. It's not going to be exactly perfect. Now that I have my vertex point, I can go ahead and find my x-intercepts. And in this case, if I try to factor this equation, it doesn't factor. So I'm going to have to use a quadratic formula. I could also complete the square, but probably quadratic formula is the easiest. So x is equal to -b, so -1, which is +1, plus or minus the square root of b squared, which would be 1, minus 4 times -2 times 7, all over 2 times a, so 2 times -2 would give me -4. And when I simplify this, I get x is equal to 1 plus or minus root 57 divided by 4. So these are my x-intercepts, and that doesn't reduce anymore. But if I want to graph these, of course, I would want to put that in decimal form. So if I do the plus root, I get x is equal to 3.12. And if I do the minus, I get 0.88. So that's what I would use for my graph. However, like I said, always keep your answer in the radical form because we want the exact answer solution. So I get 1, 2, 3.1 and oh, that's not right, 0.88. I must have missed a parenthesis. All right, so sorry about that. I was looking at a different equation. So when you do 1 plus root 57 divided by, and this should be -4, you end up with 1.64, and then it's -1, you get to -2.14. I knew it wasn't right just by looking at my graph. That didn't seem like where it should be. So 1 point would be right there, and -2.1 would be right around there. So then all I need to do is go ahead and sketch my graph. So the next thing that I want to look at is another form, and this will be the last form that we're going to talk about. So for the last form that I have x-intercept form. For x-intercept form, it's y equals a times x minus s in parentheses times parentheses x minus t, and of course this is the most useful for finding the x-intercepts. So remember, how do you find the x-intercept? You plug 0 into y and solve, so I would get 0 is equal to a times x minus s times x minus t, and when you solve these using the zero product property, you would end up with x-intercepts being x is equal to s and x is equal to t. The vertex for this is going to be, which we'll talk about why this is, your intercept s plus t, and then divided by 2, comma, plug that in for x into your equation, and you get your y value out. And then the y-intercept, again, you plug 0 into x and solve for y. So let's go ahead and do this example for a graph. So for this, for the graph of the function, find everything we want to find and then sketch a graph. So the first thing I'm going to do is find the x-intercepts because it's the easiest to find. So if I plug 0 in for y and solve, I get -1/2 times x minus 4. And then I would also want to set the other binomial equal to 0, so x plus 2 because we're solving. So then I would get 0 divided by -1/2 is just 0, and then put the 4 on the other side, and x is equal to 4. And here you get x is equal to -2, so those are my x-intercepts. And so again, it's opposite here of 2 because our formula is normally x minus t. So if it's plus, we would have to be putting a negative into our t value to get the positive. So that would be my x-intercepts. Now I want to find my vertex. And I'm going to plot my x-intercepts. We have -2 and 4. So for these, remember that your vertex is in the middle of your graph, and it splits your graph in half. So if you have your x-intercepts, then how are you going to find the vertex? Well, it's going to be the average x-coordinate of the two x-intercepts that you found. So all you need to do is take your x-intercepts, so 4 plus -2, and divided by 2, and you end up with your vertex x-coordinate being equal to a value of 1. And that makes sense that it would be a value of 1 because that's in between your x-intercepts. And then you want to find the y-coordinate by plugging that in to your equation and solving. So that would be y is equal to -1/2 times 1 minus 4 times 1 plus 2. And when you do this, you get y is equal to 9/2. And then, of course, the next thing we want to do is go ahead and plot this on our graph. So we have 1 and 4.5, which would be right there, which makes sense because it's in between your x-intercepts. And then the next thing we want to do is find the y-intercept. So to find the y-intercept, you plug 0 in for x and solve. So y is equal to -1/2 times 0 minus 4 times 0 plus 2. So y would be equal to -1/2 times -4 times 2, which gives us a value of y is equal to 4. So 0, 4, which would be here. And if I know that point's on my graph, then by the fact that the vertex is the axis of symmetry, then I know that point's on my graph. And I can go ahead and sketch my graph. And of course, you could use your graphing calculator to check your work and make sure that you did it correctly, which in this case we did. So that would be for my x-intercept form. So now let's kind of go ahead and take a look at the whole picture of everything what we just did. So I'm going to go back to this sheet right here. So for this sheet, again, the three forms that we just talked about are transformation form, polynomial form, and x-intercept form. And again, you need to have each of those equations memorized. So for the transformation form, polynomial form, and x-intercept form, I don't really remember how to, the formulas for the x and y-intercept. I remember the formula for the vertex only. And then the x and y-intercept, I just remember plug 0 in for x or plug 0 in for y, depending on what you're solving for, and then solve for that variable. So for transformation form, the vertex is, of course, remember, h comma k. For polynomial form, the vertex is negative b over 2a comma the y value when you plug that in for x. And for the vertex in x-intercept form, s plus t divided by 2, and then the y value when you plug that into your equation and solve. I will give you the formulas for x-intercept and y-intercept that they gave in the book, but however, like I said, I generally don't use these formulas. It's easier just to remember to plug 0 in for y and solve for x, or plug 0 in for x and solve for y. But the book gives you for the x-intercept for transformation form is equal to h plus or minus root negative k over a, and the y-intercept is y is equal to ah squared plus k. The polynomial form, the x-intercept would be the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. The y-intercept is 0 comma c. For x-intercept form, the x-intercepts are x equals s and x equals t. And then the y-intercept here would be a times s times t. And again, like I said, I don't memorize those. I just memorize the vertex and actually the form. So then the last part that I want to talk about is how you can make one form go into the other forms, the last part. So how can you make f of x equals negative 2 times quantity x minus 3 squared plus 1 into polynomial form? So this is transformation form. Then what would I need to do? So polynomial form is ax squared plus bx plus c, which means I want to use my order of operations and combine like terms. So for this form, I would multiply and combine like terms using the order of operations, so PEMDAS. So for this one, let's go ahead and work that out. So if I do that, I have y equals negative 2x minus 3 squared plus 1. So order of operations, I do x minus 3 squared first, which you get the FOILer box set. So y would be equal to negative 2 times x squared minus 6x plus 9, and then plus 1. Then you want to distribute that negative 2 to each term inside your parentheses. So when you do that, you get y is equal to negative 2x squared minus becomes plus 12x minus 18 plus 1, and then add the 1 and the 18 together, so y is equal to negative 2x squared plus 12x minus 17. This right here gives you your polynomial form. Then for the next one, it says, how can you make f of x equals, so polynomial form into transformation form? So there's two ways you can do this. You could complete the square, or you can find the vertex and use the same a value from your original equation. So I'm going to do both for this, so I'm going to actually go ahead and get a blank page that or maybe I'll write at the bottom of the page. Nope. So I have extra room, so let's do that. So if I have this equation, if we do both of them, we have 2x squared minus 16x plus 26. So for this, if I complete the square, the first thing I have to do is get rid of that 2 by dividing it out. So x squared minus 8x plus 13, and then to complete the square, take the 13 the other side. So x squared minus 8x plus something equals negative 13 plus the same thing, because what you do to one side, you also have to do the other. So how do you find that something? It's half your linear term, which is right here. So half of negative 8 is negative 4, and then you square it, so that's actually 16. So then when I write this, I can now factor that, which becomes x minus half my linear term all squared equals 3. And then I'm not done because I want to take my 3 back to the other side for transformation form. So x minus 4 squared minus 3 equals 0. And I'm not done because remember, my a value wasn't originally 2. That means that for this equation, I would have to put that 2 back in. And if I do, that means I have to remember to multiply it by everything in my equation that I have, otherwise it would change the equation. So this would be 2 quantity x minus 4 squared minus 6, and instead of equal to 0, it's now equal to y, so this would be my transformation form. So that's one way that you can solve this equation. The other way that most students usually find easier is by finding the vertex using what we learned and then using the same a value. So 2x squared minus 16x plus 26, I know that my a value is equal to 2, b is negative 16, c is equal to 26. So my a value is going to stay the same. Then my vertex in polynomial form is the x coordinates negative b over 2 times a. So negative 16 over 2 times 2 would give me 16 divided by 4. And of course, 16 divided by 4 is just equal to 4. And then if I plug that into my equation to solve for y, I get a y value equal to negative 6. So my vertex is for negative 6, which if you look at what we did over here, notice that that's my vertex, which makes sense. So then I would have to do is use my a value and plug it into my form. So y equals a times x minus h squared plus k. So this is my h and my k, and we have our a value. So y is equal to 2 times x minus 4 squared minus 6. And again, that's the second way that you can solve this equation. So then the very last thing that we want to talk about is how can you make something that is in polynomial form and put it into x-intercept form. Let's go back up. So number 4. So if I want to go from polynomial form into x-intercept form, then what do you need for x-intercept form? You need the a value and you need your x-intercepts. So I would find the x-intercepts and then use the same a value in your original equation. So for this one, notice your a value right here is 2, so I know that's going to be the same. And if it's in polynomial form, how do you find the x-intercepts? You can do a couple of different things. You can either factor your equation, or if you don't remember how to factor, you could use the quadratic formula. So I'm just going to go ahead and factor this. I know 2 is common between all of them. So y is equal to 2, and this would become x squared minus x minus 12. And then this becomes y is equal to 2 times x minus 4 times x plus 3, which would be my x-intercept form. So that was easier because it factored. But if you didn't know that factored and used the quadratic formula, you would have gotten that your x-intercepts would be 4 and negative 3, and then you just plug it into your equation. So y equals a times x minus s times x minus t. So it doesn't matter what s and t are, just plug it in. So y equals my a value, which was 2 from the same equation, and then x minus 4, which we'll use for s, and then x minus negative 3 becomes plus 3. And notice that you get the same thing, so those are just 2 different ways of doing the same equation. So those are everything that you need to know. So like I said, memorize those forms and the vertex, how to find them, and then how to get the x and y intercept by plugging 0 in for x and solving for y, or plugging 0 in for y and solving for x.